right, that's why you show me on your fingers then. I don't want to go through every single one of these questions unless, of course, we need to. So there are some things that I'm just going to point out as we go along that will probably help. But if you have any questions, or since you're not speaking today, just sit and deal then. See, awkward. All right. Like I said, if you want to make it awkward, you can. But which rock was formed when rock fragments are deposited and cemented together? Which one do you pick? 1, 2, 3, or 4? No, you got to participate in this. I even make them. Show me what you picked. You aren't participating. Show me what you picked.
But 5.
It is sandstone. With these questions, I would make sure you're picking out the key words. What's the key word in this one that was telling you it was sandstone? Fragments is it. Fragments is telling you that it's a clastic sedimentary rock. Going through that list, there was only, so again, process of elimination. Dolostone is crystalline. Rhyolite and gabbro are igneous rocks. So it is part knowing things and part process of elimination. I like process of elimination better than just flat out knowing the answer. What rock type contains fossils? Hopefully. Wait, really? It's sedimentary. We don't participate. Okay. You're not doing this?
What? I never said that.
I heard those words. Oh, you said you're confused.
I'm never heard that.
Exactly.
Wait, I can technically put up any answer I want because I wasn't here. So
No, you're not supposed to participate. You weren't here. All right. This is a fact you just got to remember. Fossils are only in sedimentary rocks. Why are there no fossils in igneous rocks?
Because they would get magma.
Yeah, the magma would melt them. They would destroy them. Why are there no fossils in metamorphic rocks?
Because metamorphic rocks have to go through heat and pressure.
They got to go through
They
the
get,
heat and
like,
pressure.
Broken.
They get broken and mushed up. I did the whole Hershey bar example, right?
Yeah.
The word Hershey, word Hershey on the Hershey bars is a lot like a fossil. So it's like an imprint of a footprint, which can make a fossil, by the way. So that word Hershey, by the time it has been heated up in my car, sat on by my kid, and then re-hardened at nighttime, will that word Hershey still be readable? No, that's just like a fossil. So even if we had a rock that had fossils, like this guy right here, which is a sedimentary rock, if I gave this heat and pressure, those fossils would get so distorted and messed up that you wouldn't be able to recognize them. So if you ever find a rock that has a fossil in it, it is like the dead giveaway. Bells and whistles should be going off in your head that it is sedimentary. Dead giveaway. I didn't even do that one on purpose, but I am good at some rocking good jokes. Number 3, rocking good jokes. They're pretty nice, right?
Yeah, you're right.
Question 3, question 3, what'd you pick? Yeah, it is 2. With some sedimentary rocks are composed of fragments that have different origin. What it's saying is, here's a sedimentary rock. It's got a rock right there and there and there and there and there. These are all different rocks glued together. That rock could have been igneous. This little piece right here could be sedimentary, and this one could be metamorphic. Sedimentary is other rocks that get broken and glued together. So you will find all different types of rocks inside of a sedimentary rock. Number 4, I had lots of questions about, and the key here is they are formed in thin layers. Now, it's not saying the rock has thin layers. Not saying we got 2.
So you're wrong.
It is right. It is 2. It is 2. I know why you picked metamorphic though, so stay with me. This is review. Remember when I said, in your hand, if you are looking at a rock in your hand and the rock has layers, that's a metamorphic rock. But if we're looking outside and we see layers of rock on the surface, so they form relatively thin layers compared to the thickness of the continent over a large area. So this isn't just looking at a rock in your hand. It's looking at a whole area like the Grand Canyon. So the Grand Canyon is made out of nothing but sedimentary rocks, and there's all those different layers that we looked at in the picture the other day. So that is something, in fact, do you guys just want to do the review sheet as we're going through the questions or just at the end after the questions?
What would make it faster?
After? Okay. It's about the same. In the end, you gotta write them down. Pile of sand and a pile and then a rock, they're both composed of sediments. A pile of sand was literally say you go out to the sandbox and there's a pile of sand there. What is sand? It's nothing more than broken rock, sediments. Sandstone is made out of those sediments glued together. Which would likely contain a fossil. This is how they more ask these questions. Instead of just flat out saying like question 2, which type of rock has fossils? They'll kind of give you a little bit, like you got to know a little bit more. Why are there no fossils? Why is 1 not the answer? A mass of granite and in the core of a mountain. Why are there no? At first it's inside a mountain, but what's another reason there's no fossils in this? Take a look at the question or answer. A mass of granite.
Granite isn't sedimentary.
Granite is not sedimentary. It's igneous. Why is it not number 3?
But it's not igneous.
No, because it is igneous, not
It's
sedimentary.
That's what I meant, that's what I
Why is it not 4? Metamorphic. Now, why is it 2? It doesn't say in sedimentary rock.
meant. Shale and sandstone are sedimentary.
Shale and sandstone are sedimentary. That I expect. So it's the same information as question 2, but it took it to another level that you had to know sandstone and shale are sedimentary. Where do we find the distribution of sedimentary rocks? They are over a thin layer on large continents. So we know that they're only on the surface. They have nothing to do with volcanoes. And they're not going to be the thickest in the middle of the ocean because, as we said, they form on Earth's surface. Number 8, this is deposition. So remember, sedimentary rocks form from sediments that get deposited, deposition. Again, they did tell you they were sedimentary rocks we were talking about. I'm not sure I pointed this part of your reference table out to you guys, so I want to take a moment to take a look at your reference table, the sedimentary rock chart. Yes, sir.
What everybody answered first, see if they figured it out.
Okay, Carson wants a survey of what did you pick for number 9?
3.
3, 3, 3, 3, and 1. It is 3. Let me just point this out on your reference table. I don't remember, honestly, if I did this. I kind of tend to forget about these dark headings here. All the clastic rocks, so the top half of the chart, are labeled inorganic land-derived sedimentary rocks, whereas the crystalline and bioclastic, they're labeled chemically and or organically formed sedimentary rocks. So they said land-derived, so we're looking for one of these as the answer, and siltstone was the only one. All right, number 10, we got conglomerate because it's the only one that can have pebbles in it. Number 11 is also conglomerate because 2 to 4 centimeters. This is where you have to use this chart. So again, these 2 questions were exactly the same, but you needed to see that 2 to 4. So there's 1 and there's 10. So 2 to 4 would be in between. That's pebbles again. So these were the exact same questions, but this gave numbers. I would expect to see more of a question like the second one. So it makes you do two things. Know how to use this part of the chart, that those are pebbles, and then know that conglomerate is made out of pebbles. Number 12, they are classified on your reference table by particle size. Number 13, when they are saying compaction and sedimentation of land-derived sediments, again, this is describing the clastic rocks. And clastic rocks are classified by their grain size. Most likely formed as an evaporite. Remember this part right here, crystals from chemical precipitates and evaporite. So we're looking for these three. Also could have been limestone too, but the only one on there would have been gypsum. Skeleton and shells. Again, in the comments, limestone is made out of shell fragments. Dolostone, gypsum, and salt are formed by evaporation and precipitation. Again, straight off the reference table right there. Animal shells and skeletons. Again, same question, limestone. Greatest variety of rock origin. Again, that means this rock, those pieces are all made of something else. So that is going to be, not that one. Sorry, number 1. Why it's not this one? Because limestone's only going to be made out of, limestone's only made out of calcite, whereas everything else described, the only one that's made out of different stuff is conglomerate. And finally, limestone again. I went pretty quickly through that last bunch. Are there any you want me to go over?
Nah, I got them all right.
Parson says no. What do we need to put on our review sheet about sedimentary rocks? No, that I want to break it up.
Oh,
What should we start with? We can start with that, but I want to start from the beginning.
formed from sediments or
Okay.
deposition and burial.
All that stuff. So sedimentary rocks. By the way, how do we read this rock chart? Backwards. Find the rock, find the arrow that's pointing to it, read it backwards. They come from, where'd my review sheet go? Sediments. Hits. And I just shorten up the words deposited, which is deposition, buried, compacted, and cemented together. How do I do it? It's a backwards 3 with a, yeah.
I think the answer for like the 8 one.
Yeah, I can't do that one. That one's too advanced for me.
What's the 8? Oh, that looks easy.
Start from the bottom.
Yeah, that one's too complicated for me. You can just write the word and. I don't care how you write it.
I'm a
Alrighty, where are we going? All right, well, let's add. So since we already got the beginning, I like what Logan added about fossils.
They also have like amber fossil, wood fossil.
Yes, and those would be examples of bioclastic rocks. We don't have any on our reference table because that's a little too advanced and it's not typically a New York State thing. That's places a little more exotic than us. We're a little bit too basic to have those cool fossils.
We're basic.
We are a little basic. We get blizzards.
That's
No,
about
like-
it.
We literally just have like average. We're an
Yeah.
average place in the world.
I agree with that.
Yeah, we're pretty average.
Like that's kind of a good, yeah, one of the 7 ones.
We do.
Okay, what?
One of the 7 wonders of the world. Niagara Falls.
Yo, are you okay?
Yeah,
Are you lagging?
beats me.
Are you lagging, bro?
Not even that crazy though.
We say that because we live here, but there are many people who come here and are awed by it because it's not part of their everyday like experience.
Yeah.
It's not part of our everyday.
Like, what's another water that we would go to and be awesome?
Okay, sedimentary rocks are classified by. That's the clastic sedimentary rocks, and we're gonna go to that. Before that, they're classified by texture. So all sedimentary rocks are classified by texture. Yep. By the way, there are 3 textures. Clastic is the first one. What does that mean?
Layers, no.
No, fragments.
Fragment.
Fragments of what? Yeah, I'm just gonna go with rocks. Versus bioclastic. Yes, so the clastic is the same, that's the fragments. Bio is living. Crystalline. What are those rocks? They are crystals. How do they sort the clastic rocks? Or classify them? Try again.
Grain size.
Do you have to memorize this?
Oh,
Where will we find it? In your reference table. So the clastic rocks. What makes them conglomerate, breccia, sandstone, siltstone, or shale has to do with only their grain size because their compositions are all the same. But what about the bio and the crystalline?
Chemically or something.
They are chemically formed. All right, so the bioclastic and the crystalline ones, they're classified by their composition. So again, we look at their crystal size or their grain size, and they all are basically the same. What makes them all different is their composition. Oh, where do they form? Sedimentary rocks. Yes, sedimentary rocks are formed on surface. And what will these rocks look like on the surface? No. Like the Grand Canyon
layers.
Colored layers.
in horizontal layers.
Wait, what is the vertical?
Then they got messed up. They form in horizontal layers because if you think about it, how do sediments get deposited? They go this way on the surface. So whatever there, you can't stack up sediments up and down.
Wall.
But like, you
Smack
have to have
to the wall,
rock.
they were up
With-
Yeah, that's not how rocks work.
Oh,
Wow. Horizontal layers. Let's see, what else do we need to include? That's it, I think, for sedimentary, unless you can think of anything else. You're good? All right, 36 and 37. We didn't have to do question 1. Question, and I'm sure you could figure it out. But I did tell you that we're not going to talk at all about those different rock symbols, but just in case you were curious. So again, we've got, telling you got sedimentary layers. You probably could have figured it out because it was labeled. These are all sedimentary layers. This is an igneous rock. And we want to know where there would be metamorphic rocks. This is just like when I burned Carson and Riley's shoulders the other day. It would be in between any existing rock and the igneous rock in between, which is B. So right where the igneous rock is touching, it's just like when I was touching Carson's shoulder, right there. This was Carson, this was me, this is his new burned shoulder. And way over here was like his toes, not affected whatsoever. Moving on though. Yeah, what'd you guys get for this one? This one is weird, I think. It is 4. So everything else actually described as sedimentary rock. This is the only one that is talking about metamorphic rocks. What was the kicker? What's like the key word and answer number 4 that kind of told you it was metamorphic?
Underground.
Intergrown mineral crystals, that should tell you it was igneous. Deformed fossil structure. So that you might find the remnants of a fossil, just like you might find the remnants of the word Hershey, but you will not be able to put it back together like a fossil. Number 3 is density. Why do metamorphic rocks have a higher density? Right, because when you take a rock and you put it together, you are making it more dense. So when you put pressure on something, you make it more dense. Number 4. No. Cooling and solidification. What is kind of rock is that?
Yes.
That is igneous. You need to know that. By the way, let's do this for all of them. What type of rock will make number 1 or be made by erosion? That'll make sedimentary. And compression and sedimentation of soil particles. What kind of rock will that make?
One solidification.
Yeah. No. Compression and cementation. That's sedimentary. You got to look for these key words in your reference table. That is where we're looking right here. Number 5 is schist. Number 6 is 2. So this is again still talking about yet not 4. Okay, so we want which rock would most likely be separated by a transition zone of altered rocks, so metamorphic rocks. That's literally this question that you guys, most of you just answered correctly. It's saying Carson was limestone. I am granite. Why am I granite? What kind of rock is granite? Igneous. So I was hot lava and I touched Carson's shoulder. His shoulder is now changed or altered. So anytime you see an igneous rock next to a sedimentary rock, there'll be a metamorphic rock in between because that igneous rock will have burned the sedimentary rock. Where are we? All right, we've got number 4 and then 4 again. Any questions on any of these so far that we didn't go over? All right, let's wrap this up. Number 11 should be 3. And number 12 is 2. Which one of these is metamorphic and what gave it away?
Metamorphic.
B, layers. If you see layers, you know it's metamorphic. Now we have extrusive and intrusive igneous rocks. What are key things to look for with extrusive igneous rocks?
Crystals.
What about their crystals?
Large or small crystals.
Extrusive, small or? Oh, that's, which one of these is showing you no or small crystals? It's supposed to be C. There's no individual crystals in C. It is hard to see. So then what do we need to know about intrusive igneous rocks?
Lots of crystals.
Lots of crystals, not just lots, but
Big.
large. Yep. Which one of these has large crystals and how can you tell those are crystals?
I want to say D.
It is D. What's the difference between B and A? D and A, I'm sorry.
It's just colored.
It's rounded.
That's this one again. Those are individual pebbles that are kind of squished together. You can see that they're nice and round. You can also see that they don't fit perfectly together. Large crystals, there's no spaces, no gaps, no need for filler. They all grow together. In fact, this is called intergrown crystals. Oh, yeah, we can hurry up. All right, which one is sedimentary? That is A, sediments. All right, we'll make metamorphic rock go as quick as possible here. Starting again with how they formed. They form from other rocks. Changed by heat and pressure. They are classified by texture again. And there are some different types of texture. Foliated. What does the word foliated mean in one word?
Layers.
Layers. I knew you couldn't not talk the whole time. There's two types of foliation. One is banding. In a couple of words, what is banding?
Colored.
Colored layers. I do every time I don't stop and think about color. And then the other one is mineral alignment. These are same color layers.
See, what's the difference between color layers and align?
Okay, so maybe it's the way I'm wording it. Yes, different versus same. Banding. Mineral alignment, and I know you can't see this very well on the screen. You can still see the layers. You should still be able to see the layers on the side for mineral alignment, but they are all one color. Zebra. So yeah, so if you want to add to banding, zebra, banding will look like a zebra stripes, and they don't have to all be black and white. They can be the pink and white. Okay, work with me here, dude. Non-foliated. Hopefully you realize that's no layers. Couple other things for metamorphic. I'll put this back up at the end and you guys can take a picture of it if you need it. Parent rock. Yep, what it was before heat and pressure.
I see it.
Where do you find the parent rock? Where will you find who the parent is? ESRT page 7, what column? No, the comments section. No, composition and parents are different. It is in the comment section. Yeah, the bell is about to ring. You do have homework. It's posted on the board. Page 37 and 38, just questions 1 through 15. So,
For the homework.
yeah. Questions 1 through 15 is homework tonight on 37 and 38. Is that good, London? You got it? Anybody need this backup? Okay. If you want to take a picture, you can, or if you want to copy it, you can. Here, I'll just put it up here.
Skibidi Sigma, the assignment was very. Bro, my mom answered the phone yesterday. She goes, "What's up, Al?"
My mom got me my own 6-pack.
Page 37, A1.
Sorry, guys, that was rushed. You too.
You have my list, don't listen.
She's going to eat it. My daughter's friend eats her lunch all the time, and I'm like, what have you learned? Like, I gotta pack extra for Bailey.
My
Why?
mom used to pack me extra lunch for my friends.
You guys.